In this video, we're going to be talking about the principle of positive introspection, also called the KK principle. And the KK principle says that if you know some proposition, then you also know that you know that proposition. Another way to put it is that knowledge iterates in a certain way. If you put you know that in front of P, you can put an extra you know that in front of P. And one way we'll write it down as a shorthand is like this. So I'll write K for you know that. P is just some arbitrary proposition, so you know that P entails that you know that P. This principle is interesting because it's a principle about the epistemology of your own epistemic states. So remember what it takes to know something. It takes truth, it takes justification, or maybe it takes being Gettier proof in a certain way. But let's just focus on justification or evidence. So if you know something, we know you have to have some sort of evidence for it. One consequence of the KK principle is that when you know something, the mere fact that you know it necessarily brings along evidence for the fact that you know it. So for instance, if I know that it's raining, if I meet all the conditions for knowing that it's raining, whatever they are, that fact necessitates that I also have evidence for the claim that I know it's raining. So not only do I have evidence for the claim that it is raining, but I must also have evidence for the claim that I know it's raining. And that's not necessarily obviously true. It may be somewhat plausible, but notice it's not the case for most things that if they're true, then you necessarily have evidence for them being true. Just because it's raining doesn't necessarily mean I have evidence for it's raining. The KK principle says that knowledge isn't like that. When you know something, the mere fact that you know it necessarily means you must have evidence for the fact that you know it. So if the KK principle held, then knowledge would be kind of a special state. The mere fact of its obtaining would give you evidence for the fact that it obtained, and most things aren't like that. For this reason, there's a close relationship between the KK principle and positive introspection, between a sort of Cartesian picture of the mind and of your knowledge of your own states. Because in the Cartesian picture, which Williamson tries to debunk, but it's a familiar one from philosophy, you're always sort of aware of your own mental states. So if your mental states are a certain way, then you know that they're a certain way. So notice again, on that way of thinking, the mere fact that your mental states are a certain way necessarily means you must also have evidence that they're a certain way. So there's a close, hopefully you'll be beginning to see that there's a close relationship between that picture of the mind and mental states, where whenever you have a mental state, you must necessarily also know it, and the KK principle, which says that whenever you know something, you must therefore also know that you know it, and as a consequence, you must have evidence that you know it. That's one reason why KK is interesting, because it is closely tied to a certain kind of epistemological picture. The other reason it's interesting, though, as you'll sort of see as we go along, is that it's connected to some of the issues about higher order attitudes that we've been talking about. I won't go into this too much right now, but remember that when we talked about these higher order attitudes, they involved like one person believing the other, believes the other, believes the other, so on. These kind of chains of belief or knowledge operators. And what you'll notice if you look at the KK principle is that it also is sort of about how knowledge operators get chained together. It says, well, whenever you have a knowledge operator in front of a proposition, you can always add an extra one on. And notice that because you can always add an extra one on, the KK principle has the consequence that you always sort of know, if you know P, then you know it at all levels. Because if you know it, then you know that you know it. Well, then applying this again, you know that you know that you know that you know it. You know it to level 4, you know it to level 5, and so on. So the KK principle, at least for the case of just one person, if you had it, it would say that, well, whenever you know something, you must also have knowledge at all orders. Now, we've talked about this idea of attitudes at all orders before, as I said, so you might rightly suspect that this principle is implicated in some of the issues we've been talking about, issues like common knowledge. Indeed, it is implicated. So that's what the KK principle is and why it's interesting. So we're obviously going to be focusing on the second reason for thinking it's interesting, but the first is also an important one. For the rest of the video, what I want to do is I want to show that there is an important connection between the KK principle and certain structural constraints on knowledge when we think about it in terms of the simple possible worlds theory of knowledge that we talked about at the very beginning of this course. So let's start by once again drawing our familiar space of possible worlds. So we know that it's a picture like that, some sort of square, and then we have a circle, and that represents our knowledge set. So that's the set of worlds compatible with what we know. Something we need to be a little bit more precise about now that I kind of left tacit the first time we talked about it is that, well, since you know different things at different worlds, your knowledge set is going to be different at different worlds. So let's take the first part of that first. Why do you think you know different things at different worlds? Well, for instance, in the actual world, there's a cup of coffee on the table in front of me. But of course, it could have been different. It could have been that I didn't make a cup of coffee before I went to give the lecture. If that were the case, well, then I would have known that there was no cup of coffee on the table in front of me. So if things had been slightly different, then my knowledge would have also been slightly different. So at different worlds, the things that I know are going to be different. So the first thing we got to do is realize that this knowledge set represents what we know at a particular world. And let's say that this represents what we know at the actual world. All right, the at for actual. But even though the knowledge set looks like this at the actual world, that doesn't settle what the knowledge set would look like at different worlds. In particular, the knowledge set, suppose that, this is a world where there was no cup of coffee, where I made no cup of coffee. We might represent the fact that I would know that my knowledge would be very different by just drawing a different circle that doesn't overlap at all. So that's the first important clarification I want to make about these pictures, is that when we were drawing the circles before, we need to be more careful now for this lecture, and you'll see why in a moment. We need to be more careful now that the sets represent what's known at a particular world. And what I'll often do to represent what world it's representing it, I'll just draw a point. The point at the center, it's what you know at this world that the knowledge set is representing. So once you see this point that the knowledge set can vary at different worlds because what you know at different worlds varies, one question that naturally arises is, well, so this is a world outside your knowledge set. I deliberately picked this to be a world outside your knowledge set. And it sort of makes sense that since it's outside your knowledge set at the actual world, the knowledge set of this world will be disjoint from the one at the actual world. But a question you might have is, well, suppose instead we focused on a world that is in your knowledge set at the actual world. What does the knowledge set for a world like this look like? And it's actually a more specific question we can ask here, because we can ask, well, is it the case that when you pick a world in the knowledge set, a particular world, it always gives you the same knowledge set? So is it the case that at this world, let's call it W1, is the knowledge set at W1 necessarily the same as the knowledge set in the actual world, since W1 is compatible with what you know? Or could it be that the knowledge set is different? Could it be that the knowledge set, I'll erase this one. Could it be that the knowledge set for world 1 actually looks something like this? Meaning, could the knowledge set corresponding to world 1 include worlds that are not compatible with your knowledge in the actual world? So that's one question we must ask ourselves once we realize that these sets represent what's known in a particular world. So the question is, when you focus on a different world that is inside the knowledge set of the actual world, is its knowledge set going to be different, or is it going to be the same? If it was different, it would look like the green. If it was the same, it would look like the black. It turns out the answer actually partly depends on the KK principle. And in particular, if the KK principle were false, then sometimes you get a situation where the knowledge set for a world like world 1 would be different from the knowledge set at the actual world. In particular, if the KK principle were to fail, you could get a situation which is exactly like this, which is pictured here, where the knowledge set for some world in your actual knowledge set includes worlds that are outside your actual knowledge set. Why would that be? Well, let's imagine, what we'll do is we'll imagine what would it take in terms of these pictures for the KK principle to fail? What would it look like if the KK principle fails? So I'll just erase everything in the diagram and we'll start again. So what we want to first do, so to imagine a situation where it fails, we need to first imagine a situation where this is true, and then turn it into a situation where this is false. So a situation where the antecedent is true, and a situation where the consequent is false. So first of all, we want it to be a situation where you know P. So let's take this circle, let's this be the actual world, and we know what it takes to have a situation where you know P. We just draw in the proposition P, I'll call it this green one. I'll also just write K A to indicate that this black set is your knowledge set at the actual world. So if this is your knowledge set of the actual world, and it's contained within the set P, then obviously this is the picture where you know P. So far, so good. Now we want to draw a situation where you don't know that you know that P. Now these are all the worlds that are compatible with your knowledge. So if it were to fail that you knew the P, if it were to be false that you knew that P, there would have to be some world in your knowledge set where you didn't know that P. Because if it's false that you know that P, then it's compatible with what you know that you don't know that P. So there must be some world, I'll draw it in here, and we want this to be a world where you don't know P. Because if there's some world in your knowledge set where you don't know P, then in the actual world, you also don't know that you know P. So what would it take for it to be false at this world that you knew that P? Well, it would just have to be that the knowledge set for this world, let's call this world world 1, it would have to be that the knowledge set for world 1 included some not P worlds. Because the knowledge set is all the worlds compatible with what you know at that world. If it contains some not P worlds, then it must be false that you know that P. Now we know what set P is, it's the green circle, so putting in those terms, that means that the knowledge set for world 1, if we want it to be a world where it's false that you know P, then the knowledge set for world 1 must fall outside the green circle. So let's do it like this. We know now that world 1 must be a world where you don't know P, because in this region, let me shade it, P is false, just because it's outside the green region. So it's false that you know P here. That means that the actual world, there's a world compatible with what you know, where it's false that you know that P. So that must mean that it's false that you know that P. Because there's some world compatible with what you know, where you don't know P. But now notice what we've done. So we know that in order to make it true at this world, that you don't know the P, there must be some not P worlds in the knowledge set at world 1. But of course, all the worlds in the knowledge set of the actual worlds are P worlds. So that means we know there must be worlds at the knowledge set in world 1 which are not in the knowledge set at the actual world. So this then answers the question we had before, because remember we were asking, well, when you look at other worlds in the knowledge set, is their knowledge set the same as the one in the actual world, or is it different? And what we saw was that when we constructed, using our picture, a situation where the KK principle failed, we had to draw the knowledge set for this other world, world 1, in such a way that it included not P worlds. But since we had to stipulate in the beginning to make this true, to make it true that you know that P, that their knowledge worlds are all P worlds, saying that there are some not P worlds in the knowledge set of W1 entails that there are some worlds in the knowledge set of W1 that are not in the knowledge set at the actual world. So the first thing I said was that we got to remember that knowledge sets really represent what's known at a particular world, the world in the center of the circle. We then ask the question, well, if you pick a different world, but that's nonetheless in your knowledge set at the actual world, what's its knowledge set going to be like? In particular, is it going to be the same as the one at the actual world, or is it going to be different? And we saw that by thinking about the KK principle, we actually get an answer to this question, or a partial answer. What we saw is that if this principle were to fail, then sometimes the knowledge set would have to be different here than it is here. Putting it a different way, KK failing, this principle failing, is incompatible with the idea that when you pick another world in the knowledge set of the actual world, it always must have the same knowledge set. Because if KK fails, then that principle must fail sometimes as well. So I've related the KK principle to the way of drawing diagrams relying on the knowledge set from beforehand. I also want to show you a different way of thinking about it, though, because this isn't exactly the way that Hawthorne and Maganer put it. I'll mostly kind of think about these terms whenever we think about knowledge sets at all, but I just want to relate it to the talk of accessibility relations that they use. The first thing to say here is that even though we draw these as sets, so we have the knowledge set at a particular world, it's defined in terms of a kind of relation. Because remember, what did we say it takes to be in the knowledge set at the actual world? We said that a world is in the knowledge set at a particular world just in case what you know at the second world is compatible with what you know at the actual world. Putting it slightly differently, we defined a certain kind of set, call it KW. We said that some world is in KW just in case some relationship holds between them. In particular, this relationship, this R just stands for the fact that W prime is compatible with everything that you know in W. Or put slightly differently, everything that you know at W is true in W prime. So we've defined this set, the knowledge set at a particular world, in terms of a relation. Now we didn't write it down this way, but this is what we were doing. So what this illustrates is that there are kind of two ways of thinking about this modal picture of knowledge. One is in terms of belief sets, but another way is in terms of relations. And these are actually just interchangeable. So let's call this the accessibility relation for knowledge. This is what this R is, the accessibility relation for knowledge. And putting it that way, you'll see that the knowledge set at a particular world is just all the worlds that are accessible at that world. So the knowledge set of the actual world, well, that's the set of worlds that are compatible with what you know at the actual world, i.e., they're the accessible worlds, the worlds that are accessible from the actual world. So this way of thinking about terms of sets is actually just completely interchangeable with thinking about it in terms of relations. And because that's true, there's actually a way of writing down what the KK principle corresponds to in terms of relations. So we saw that when it fails, you get a certain kind of relationship between the knowledge set at the actual world and the knowledge set at other worlds compatible with what you know. Now, I won't prove what I'm going to say, but it actually turns out that, well, when you define the knowledge set in terms of this kind of relation, the KK principle corresponds to a particular kind of property of the relation. Namely, that this relation is what we call transitive. So what that means is if you have some world 1, which is related to world 2, and you also have world 2, which is related to world 3, then world 1 is also related to world 3. So you can think about it, if you can take an R step from world 1 to world 2, if you can move from world 1 to world 2 via our relation, and you can then move from world 2 to world 3 via this relation, then you could go directly from world 1 to world 3 via this relation. So it turns out that, and as I said, I won't prove this, so you just have to take my word for it, but it turns out that this property exactly characterizes KK. KK holds just in case the accessibility relation has this property of being transitive. Now, as I said, I won't prove that, but the last thing I will say is that if you look at this diagram carefully, the diagram where we constructed a counterexample to KK, you'll actually be able to see, when you think through it carefully, that this relationship fails, that the relationship corresponding, or the accessibility relation corresponding to the knowledge sets must not be transitive. So what people often do to represent accessibility relations is they draw arrows between worlds. So we have this world, the actual world. We said that world 1 is compatible with what we know of the actual world, which means that we want to draw an arrow between the actual world and world 1 to represent the fact that world 1 is accessible. Now, we saw that this blue set represents the knowledge set at world 1. So any point in this blue set is accessible from world 1. So we could draw an arrow to any other point in world 1. But in particular, we know there are worlds out here in the blue area where not P holds. So we could draw an arrow between world 1 and a world out there. I'm going to erase this just to make it easier to see. So notice now here we have a chain. So we have the fact that world 1 is accessible from the actual world. Since this blue set represents the knowledge set of world 1, we know in particular that some world out here, let's just call it world 2, is accessible to world 1. And now we can ask, well, does the transitivity property hold? Is it also the case that world 2 is accessible from the actual world? And we can see that the answer actually is no when you think about it, because this is a not P world. We stipulated at the very beginning that you knew P in the actual world. But if this world, world 2, which is a not P world, remember, because it's in this blue area, if this were accessible from the actual world, then it would have been false all along that you know P. Because if this world, world 2, were accessible from the actual world, this world would have been in the knowledge set all along. But of course, we stipulated that it's not in the knowledge set because we wanted it to be a case where you know P. So actually what we did was we thereby stipulated that the relationship doesn't hold. There is no arrow going from the actual world to world 2. So that's not a complete explanation for why the transitivity property is what corresponds to KK, but at least illustrates why that once we've constructed a picture like we gave earlier on, where KK fails, the transitivity property also fails. So what we showed is that we took this principle, the KK principle, which is an important principle about the epistemology of your own epistemic states. And we showed there's a certain relationship between the KK principle and these diagrams we've been drawing all throughout the course. In particular, it corresponds to a particular structure the knowledge set might have. If the KK principle fails, what that tells you is that sometimes the knowledge set for other worlds in the knowledge set of the actual world will be different from the knowledge set of the actual world. Putting it in terms of accessibility relations, sometimes worlds that are accessible to the actual world will themselves be accessible to other worlds which aren't accessible to the world you started with. Sometimes this sort of chaining effect that you get via transitivity will fail if KK fails. The last thing I want to do is talk about one further principle about the epistemology of your own epistemic states. And I just want to mention it very quickly because it sort of indirectly comes up in Hawthorne and Magador's discussion. When I present their discussion, I'm going to mostly do it in terms of KK, but I do want to show you what they talk about because they talk about this symmetry property. I want to tell you why, shed a little bit of light on why they talk about that. So here's a different kind of principle you might think about, which is that if something is true, if some proposition holds, then you must know that you don't know that that proposition is false. It's helpful to fill it in with a particular example. So suppose P is it's raining. This principle says, well, if it's raining, then it follows that you know that you don't know that it's not raining. Just putting it like that obviously makes it kind of hard to assess exactly what the merits or demerits of that kind of principle are. And actually, I'm not going to get into the demerits or demerits of this principle today. The only thing I want to say about this principle is that it corresponds to a certain kind of property on the knowledge set or on the accessibility relation. Remember, those are two different ways of thinking about the same thing. And in fact, I'll just talk about the accessibility relation. It turns out, and again I won't prove this, but that this property corresponds to the property of symmetry in the accessibility relation. To say that the accessibility relation is symmetric is to say that, well, whenever one world is accessible to another, I'll also say that another way of saying this more quickly is to say that world 1 sees world 2, where sees just means accessibility relation. When world 1 sees world 2, then the reverse must hold. It must be that world 2 also sees world 1. That's what's known as saying that the relation is symmetric. And it turns out that this principle, that if something is true, then you must know that you don't know it, it's false, exactly corresponds to saying that the accessibility relation is symmetric. So that is basically why Hawthorne and Magador talk about symmetry throughout the paper, because symmetry actually turns out to correspond to this principle. Just like there are arguments against KK, which we're going to see in a moment, there are also arguments against this principle. This is an epistemological principle, again, about the epistemology of our own states, and there are arguments against it, just like there are arguments against KK. What that means in terms of accessibility relations is that there are arguments against thinking that the R relation is symmetric. So to say, don't worry too much about this principle. It's not really going to be the centerpiece of our discussion. We're not really going to get into the arguments pro and con. But this is why Hawthorne and Magador talk about symmetry. Because at the end of the day, they're really thinking about this principle, and this principle depends on symmetry. Actually, it's really just the same as symmetry.